Hello, everyone. Hopefully, you're doing well. We're going to continue with chapter one, thinking critically. If you missed the previous videos covering section 1A, 1B, and 1C, I strongly advise you to take a look. I believe in the first section, we went over some basic reviews on, common fallacies, especially, living in the media age. And for section 1B, we went over, propositions and truth tables. And, we covered a lot of these. In section 1.C, we went over sets and Venn diagrams. Here, we're going just to continue what we covered in in section 1A, where we said that an argument uses a set of premises to support one or more conclusions. If an argument is well constructed, its conclusions follow from its premises in a compelling way. But how do we determine whether an argument is well constructed and compelling? So that's what we're going to examine in this unit. So analyzing arguments. So that's what we're gonna do in this one right there. Okay. Let's see it. Well, uh, you know, there are, when you talk about arguments, we can say there are, arguments comes in two basic types. Either it's inductive or deductive. We talk about deductive reasoning or inductive reasonings. We said that those things, all the time. But uh, we're gonna just use some definitions because we said in inductive argument really makes a case for a general conclusion from more specific premises, right? You see that examples right there, okay? What we talked about when we talk about inductive reasoning, if you have the premise, say like bluebird flies. And we have another one, hummingbirds flies. We have the cardinals flies. So at the end, we can conclude all birds flies because if we have a few specific, if we have a few specific ones, okay. So that's what we're trying to do here. We use a set of fairly specific premises, like if I go with another examples, like let's say if we don't want to talk about birds, only birds. Let's combine it. Let's say birds fly into the air, but eventually those birds not gonna stay there forever. They're gonna come back. People jumped into the air, also they fall back down, right? If you throw a rock following a velocity or something, you throwing a rock in the air, it's gonna come back as well. So ball, that means if you throw a ball, either a soccer ball, a football, throw it in the air, it's gonna come back down. So we can conclude that what goes up must come down, So what we mean by that, I give you two specific examples or arguments where we start with a fairly specific premises, each of which makes a claim about a specific type of objects. We see, we talk about birds, people, rocks, and balls. They all get into the air and come back down. Right? So the conclusions is more general statement about how any objects might behave. So that's why we said this type of argument in which a conclusion is formed by generalizing more specific premises, we call it an inductive reasoning. So the term inductive has the root induce, which means to lead by persuasions, right? So we have birds fly in the air, come down. We have people jumped into the air, falls down. We have rocks thrown into the air, fall down. Okay, come back down. Balls, whether we said it's soccer ball or football or tennis ball, is thrown in the air and come back down. So we can conclude that what goes up must come down. It's the same thing, different birds, That's right. So at the end, we can say all birds fly. So that's what inductive reasoning. So we can come from a specific premises, and that would lead us to a general conclusion. So we make a case for a general conclusion from a very specific premises. But how about the other types of arguments? As we said, we have two types, inductive and deductive, right? Deductive reasoning, in contrast, because we need to do both of them, as we said, deductive reasoning makes a case from a specific conclusions from a more general premises. Or if you want to do it, general premises, I mean general introductions, when go to a specific conclusions. As you can see here, one of the examples you can use, premise, all doctors are intelligent. Dr. John is a doctor, so we would conclude Dr. John is intelligent. Is it strong? Is it a strong argument on that? But you know what? This is what we call deductive reasoning. If we talked about all politicians are married, do you know a politician who is not married? No, all politicians are married. And because Senator Reid is a politician, we would conclude that Senator Reid is married. We don't even ask him whether or not he's married because he's a senator, and by contrast, we know all the politicians are married, so we would conclude he is married. So that type of, that type of argument begins with a general statement about about doctors. For example, here we said all doctors are intelligent, so we said it start with a general statement about doctors, and then draws a specific conclusions about a particular doctor, Dr. Jones. All right, Dr. Jones. So this argument is called deductive argument. Okay, it's a deductive reasoning because it allows us to deduce a specific conclusions from a more general premises. So that's very important to look at this one. But about evaluations, you can evaluate inductive or deductive reasoning. You know, an inductive reasoning cannot prove its conclusions true. So we evaluate it only in terms of its strength. So if it tells you something and you feel like, oh yeah, it's strong enough to make a conclusion, then you would accept it. So an argument is strong if it makes a compelling case for its conclusions. It is weak if its conclusion is not well supported by its premises. All right. So we have a strong argument, right? If it's a compelling case, this is made for its conclusions, but it might be also weak. So that's how we evaluate, inductive arguments. So note that evaluating strength involves personal judgment. Sometimes, it's based on your feeling. An argument that one person finds very strong might appear weak to someone else. For example, let's say a movie director can tell, oh, you know what, my next movie would be a hit because my last two movies were a hit, because I contract the best actors, the most popular actors. So, but maybe everyone knows a lot of movies with a lot of very popular, good actors can end up being flop, right? It can flop. So, you know, it's based really on feelings, right? An argument that one person finds strong may appear weak to someone else. So the strength of an inductive argument is not necessarily led to the truth of its conclusions, right? Like the one I just showed you, or before that, the previous argument about inductive reasoning, was strong enough to convince people to said, oh, you know what? All birds fly because I can, and that was a good one, right? Now, some of them are very critical that you can verify, but you know what? Before we go about with evaluating deductive, because inductive we evaluate them based on their strength and their weakness. But before we go over evaluating deductive arguments, how about going over some examples very quick? In these examples, we're gonna see what's happened. In these examples, we know that you just said explain why the following arguments are deductive or inductive. Do you feel like the first one? I have never seen a bank open on the 4th of July. All bank must be closed on the 4th of July. So we go with something that we feel like it's very simple, or no? Do we go with something specific, you know? We more specific and to draw a general conclusions. Is that correct? Because if that's the case, we can say it is inductive. Okay, that's what we do. We go about something specific because personally, I never seen a bank open on the 4th of July. Then I make it general for everyone. All bank must be closed on. So I draw a general conclusions. In this case, this is an inductive reasoning because it makes the case for a general conclusion based on a specific observation. So it's inductive. All right, let's say argument. I was going to say, okay. Number two, every day of my life, the sun has risen. Tomorrow the sun will rise. So again, here we said every day in my life, of my life, the sun has risen. Tomorrow the sun will rise. So how are we gonna see this one? At this point, I would consider this one anyway, every day. But that's my personal observations, then I generalize it for tomorrow. I mean, like every day would be the same. Again, this is an inductive reasoning argument because it makes the case for a general conclusion based on a specific observations. So again, this is inductive. Okay, I don't know how many examples I take, whether all of them are inductive or not, so we can try that. Okay. We can try that. If I don't sleep, we're gonna try another one. If I don't sleep well, I wake up feeling absent-minded. Okay. If I am absent-minded, I forgot to eat lunch. All right. So therefore, I don't sleep well, I miss lunch. You see, now I make it a very specific to me. I come from something general. Okay, then I said, okay, you know what? I didn't eat lunch, then I mean, I don't didn't sleep well, then I miss lunch, right? So that's more something like deductive. Okay, so I think we're gonna go with deductive. If I don't eat lunch, okay, if I don't sleep, okay, uh, you know. That would be deductive argument because a specific conclusions is deduced from more general premises. That deductive argument. Because you know, we come from something general. I said if I don't sleep well, I wake up feeling absent-minded. If I'm absent-minded, I forgot to eat lunch. So that's really general. But now give it very specific case. I don't sleep well, so I miss lunch. And let's see the last one. It always rains on Sunday. That's general, right? That's something specific. Tomorrow is Sunday, so it would be right-handed. So again, here, this one is a deductive reasoning because a specific conclusion is deduced from a more general premises. So we're gonna say deductive for this one also. I know I cut off evaluating inductive arguments from this tool because I forgot like we were supposed to review some of these arguments to identify whether they are inductive and deductive. Before we do some evaluation, I said evaluations, an argument, you do it an inductive argument does not prove its conclusions true, so it's evaluated based on its strength, whether it's strong or it's weak. And because we said this is something that involves personal judgment, what is strong for someone is not maybe weak for someone else, but evaluating deductive reasoning, maybe that would be a little bit different. You know, we apply two criteria when evaluating, deductive reasoning. The first criteria, we check if the argument is valid. If the argument is valid, if its conclusions follow necessarily from its premises, regardless of the truth of these premises or conclusions. So we check two things: the validity and if it's sound. So the argument also we check if it sounds, right? The argument is sounds if it is a valid and its premise are all true, right? So we can be sure that the conclusion is true only if the answer to both questions, is yes. Okay. In more general terms, the first questions, can check the validity of the argument. So a deductive argument is valid if its conclusions follow necessary from its premises. All right. So what you need to remember, validity is concerned only with logical structure of the argument. So validity involves no personal judgment, right? And has nothing to do with the truth of the premises or conclusions, right? So, for example, if deductive reasoning is valid and its premises are true, then we say that the argument is sound. We check the validity first, eh? So if the deductive argument is valid and its premises are true, so we said that the argument is sound. Soundness represents the highest test of reliability of a deductive argument because, at least in principle, a sound argument proves its conclusions true, right? But however, let's say that soundness may still involve personal judgment if the truth of the premises is debatable, right? All right. So we're gonna see. Remember, I talked about all politicians are married. So uh, you know, uh, uh, someone, then you know, let's say Senator Jack is a politician. Then Senator Jack Reed is married. So this argument, is valid because the conclusions follow necessarily from the premises, but it's not sound because the first premises, all politicians are married, is maybe false, right? Maybe those I know married, but not all of them, So that's make it sound, make it valid but not sound, okay? So things that you need to bear in mind when you analyze arguments. So, key distinction between inductive and deductive reasoning. One of them is based on, intuitions, and the other one is based on theorems. Theorem is mostly because when you do 2, 4, 6, 8, 10, 12, the next one will be 13, 14. That means you count by two. Those are things you verify and it's working for deductive reasoning. So, for example, key distinction. A conclusion is formed by generalizing from a set of more specific premises. It's formed by, you just generalize what you feel is specific, right? So, um, you know, a specific conclusion is deduced from a set of more general or equally general premises. So that's two different between deductive and inductive. An inductive argument can be analyzed only in terms of its strength. Evaluating strengths involves personal judgment about how well the premises support the conclusions. But for the deductive, a deductive argument can be analyzed in terms of its validity and soundness. It is valid if its conclusions follow necessarily from its premises. It is sound if it is valid and its premises are true. But let's see another one of these key distinctions. An inductive argument cannot prove its conclusions true. At best, a strong inductive argument shows that its conclusion probably true. Remember, I gave you the examples of, you know, I gave you the examples of the movie producer. The movie producer said, I'm gonna produce the best movie of all time, because my last three movies were very good, but doesn't mean the next one would be true. So that's inductive reasoning, However, if we debate about the earthquake, you know, uh, you know, uh, because based on studies, we know there is a possibility that an earthquake hit a certain area at a specific time. So that's what I mean. That's is based on facts, so it would be deductive, for example. All right. So, and we said validity concern only logical structure. A deductive argument can be valid even when its conclusion is blatantly false, right? Those are other readings you can see how to test a test of validity, a Venn diagram test of validity to test the validity of a deductive argument with Venn diagram. First of all, you draw the Venn diagram. You want to verify if it's a subset, if it's a disjoint, or what's in it? If it's overlapping? That's we covered in the previous video. If you miss it, please watch the previous one. So what you need to do to draw a Venn diagram that represent all informations containing in the premises. Check to see whether the Venn diagram confirm the conclusions. If it does, then the argument is valid. Otherwise, it's not. Remember, you can have Venn diagram where you have one inside of the other one, or you have a Venn diagram where they are disjoint, not no overlapping, or you have Venn diagram where they are overlapping. That means they have something in common, right? So verify that. Uh, Look at these examples. Evaluating uh, the validity and soundness of the following argument. All fish in the water. Remember, for the deductive, we always start with all something. Walrus are not fish. Walrus do not live in the water. Is that true? Okay. The premises, so wa things that live in the water. So let's say walrus would be somewhere here, but not fish, okay? The premise, all fish lives in the water, tell us to draw the fish circle as a subset of the thing that lives in the water. That's what they tell us. So the premise, walrus are not fish, tell us to put an X for walrus outside the fish circle. So it should be outside, right? But it does not tell us whether the X should be inside or outside the things that live in the water circle. So we place it on the border of the circle. So the conclusion, whales did not live in the water, would require an X outside the thing that lives in the water circle. But the X from the premises is on the border of the circle, which means the premises do not automatically support the conclusion. So I know that's quite a lot to tell you, but different ways of seeing it. That was just an example. So basic forms of conditional deductive arguments. So you have four basic forms, you know, um, either structure and you check its validity, affirming the hypothesis, the incident. If P then Q, so P is true, so Q is true. Affirming the conclusions, consequent. So if P then Q is true, then P is true. So you see, we go with the second one first. Denying the hypothesis, and that's, denying is affirming and denying, right? If P then Q, so P is not true, then Q is not true, or Q is not true, then P is not true. So we have four, and those are the formal conditional deductive, so we can verify. Let's go over one or two examples very quick. I think we can see this. Look at these examples very quick, very close. So what we ask you to do in this one is to determine the truth of the premises of the following arguments. Then assess the strength of each argument and the truth of its conclusion. So that's what we're gonna do with these examples. Let's try it. We said, um, Michelangelo, Manet, Monet, uh, Modigliani, Munch, and Marco were great painters. Those the painters lovers, art lovers. You probably know all those great painters, right? So this is the premises because those are known people, things you can verify, but it's really specific. So if it's specific, then we're gonna draw conclusions. That's called, that calls, you come from specific to generals, that's inductive. So painters with names begin with M are greatest. I know so many painters with M, their names start with M, but they are not good at all, right? I don't want to state names, but you know what? It's not true. The premises are true. Premises are true because all those names are well famous. If you like arts, you must know these names. All are started with the letter M. They are great. But it's true. It's true the argument, but the argument is really weak. You know, it speaks to only six of many, many, many painters. So you cannot conclude in any way that all painters with names starting with M's are great. So the conclusion is false. Premise is true. Premise is true. Conclusions false. Right? Weak. This it's a weak argument, right? So we can say the argument is weak. Okay. Now that you see this, we can try something else. If I eat ice cream, I gain weight. If I eat cake, I gain weight. So I would conclude eating uh, dessert cause me to gain weight. There's so many things you can take in dessert. Those of you who go to restaurant, even foods, you can get some foods and you don't get gain weight, right? There are so many others that you can try that you don't gain any weight. So again, here that's something you know it's rational, right? So not really rational. So because you know, if the premises are generally true, so those who eat ice cream, they gain weight, or eat cake, they gain weight, but the argument is really weak. So it's weak argument. So this one over here, it's also a weak argument. It's not strong because it's not because you eat dessert that you're gonna gain weight, right? So the conclusion may not be true. It's possible to eat dessert and not gaining weight at all. So I would advise you probably, I'm not gonna say totally false, but I know these the premises are true, maybe they are true, but this one, you can put question marks because it may not be true. If you can identify a few desserts when you eat, you don't gain weight, then you don't continue. You said the conclusion is false. Now, let's try another example. So we're gonna do with C as in cat. We have three premises. So robins and wrens are birds and then they fly. Eagles and falcons are birds and then they fly. You know, hawks and vultures are birds and they fly. So I mean, you can verify those. If they are true, do you think the premises are true? Yes. So they are all true because they are all birds and they fly. So those premises are really true. Okay? Those premises are really true. So we can say it's true. Now let's see the conclusions. The conclusions, it says penguins are birds and they can fly. For those of you who know penguins, do you think penguins can fly? No, that's false. That's really false. The conclusions is false. At some point, looking at if you remove penguins, Those are some strong arguments anyway. So I'm not gonna say strong. It's moderately strong. Well, moderately. Strong. All right. Moderately strong. All right. So So very important. So I just go over these very specific examples, but we have so many other talking about the Venn diagram. As I said, we can see how many we can use in terms of deductive with deductive arguments with a chance of conditionals. You know, I can we can go over some of these examples. Another common type of deductive arguments involves a change of three or more conditions, such as arguments have the following from premise: if P then Q, if Q then R, then if P then R. You know, this one involves three of them. Um, if uh, if Jane like if Jane is friends with Jacob and Jacob is friends with Mark, so James obviously is a friend of Mark also, so because they're gonna connect anyway. So this particular chain of conditional is valid if P implies Q and Q implies R. It must be true that P implies. So I take it in terms of friendship. So three people, I mean, you don't know. The first one doesn't know the third one, you know. If we have Jake, Mark, and and Sam, right? Jake, Mark, and Sam. So Jake friends with Mark. Mark, friends with Sam. You see what happened? Obviously, Jane gonna be friends also with Sam. So that's a fact, and even in daily life you would see this. So perhaps more than any other subject, mathematics relies on the idea of proof because it's very important. Whatever we say, we can prove it because it's math. Every words leads to warm. That's what we said. Inductive and deductive in mathematics. Um, you know, um, a mathematical proof is a deductive argument that demonstrates the truth of a certain claim or theorem. Like Pythagorean theorem, we can, it's based on deductive reasoning. A theorem is considered proven if it is supported by a valid and sound proof. Although mathematical proofs use deduction, theorems are often discovered by inductions. First, they start somewhere, especially if you consider the Pythagorean theorem, which applies to right triangles. I mean, right triangle, those with one angles 90 degrees. It says that the sum of the square of the two short legs is equal to this square of the longest leg. Or we can say the sum of the square of the two shorter sides is equal to the square of the hypotenuse. So, whereas, hypotenuse is the longest side anyway, So we can say that. Okay, let's see very quick a few examples again. Consider the following arguments. What they ask us to do for each of these, we must draw they said we must draw a Venn diagram to determine whether the argument is valid. If I look at the first one, you know, I'm gonna just copy and paste because I might need to use it again. If I look at the first one, I'm gonna just make it smaller so we can have enough time. Well, it doesn't make any change. Let's do it. I need more space. Okay, let's do it here. What they ask us to do, we know Venn diagram is gonna be in a circle, right? So from that circle, let's see what they said. All European countries are countries in the European Unions, right? So European countries are in the European Union. So countries in the European Union. So we said, oh, that's subsets, right? It sounds like it is a subset. That something we need to verify, right? Sounds like a subset. So we're gonna have, let me use a different color. If that circle right there, we're gonna call them countries in the European Union. So countries in the European Union. Let's put EU for European Union. Now, if a country is in the European Union, it must be in Europe. So only those in the European Union. So those are European countries, right? European countries is in the European Union. So you cannot say US is in the European Union. So those are European countries, right? Okay. Let me write smaller because I'm terribly wrong in writing this. European countries. Okay. Now, they said all European countries are in countries in the European Union. So you see that's a subset, one inside of the other one. Denmark is a country in the European Union. Is it a European country? Yes, what we would see in this one, so I said yes. The argument is valid. Okay. The argument is valid, but Denmark is a European country, but it's not in the European Union, right? So that's a problem. So we cannot include it there. So we need to have Denmark somewhere outside. So we may have Denmark here. Okay, because it's not in the European Unions, right? So we cannot include it in some. So what we would see here, the argument is valid. Argument is valid, argument. Because for this, we need to check the validity. Okay, it's validity, so it's valid. But is it sound? Remember, we're working with deductive reasoning here. The argument is not sound since the first premise is false, right? So all European countries are in the European Union. So you see the first premise, this part right there, all European countries are in the European Union. That's false because we have so many European countries that not in the European Union. Remember what's currently happening in Ukraine. Ukraine is in Europe, but not in the European Union. So this argument is false, right? So the argument is valid, but the argument is not sound. Argument is not sound because of what? Because the first premise is false. Okay, so this is it. We can do one more example very quick. Let me go with, I'm gonna go with the last one because I'd like to leave one for you at least to work on, and you let me know what you got for it. Do not hesitate to contact if you experience any difficulties. I can give you some tips on how to do it. But in the meantime, I'm gonna let you work on your own for that, okay? That's very important. But you know what? let me try to do oh, you know what? Let me do it with all of them. I need more space. Okay. Now for this one, let's go over again. We're gonna construct a Venn diagram in which we don't know yet what's gonna be inside. Okay. For this, we're talking about the height. Okay. We're talking about the height. We said that all 8,000 meter peaks are in Asia. So that's something again you need to verify if this argument is valid, you know. And we said that Denali is not in Asia. I believe Denali is not in Asia. That is true. Okay. So because what they tell us now, this is what they tell us. They said all peaks are in Asia. So peaks in Asia, right? We know the peaks in Asia. Now, if the peaks are in Asia, we know, most of the 8,000, that's what they said. They said 8,000, all of 8,000. So 8,000 meter peaks. Now, where I'm gonna put, we need to choose Denali. Where should I put Denali? Is that inside or outside? Yeah, that should be somewhere out of the circle. So, you know what? It's gonna be maybe here. Because that's true. Denali is not in Asia. I think it's an American soil. I don't know exactly where it is, but should be in American soil, not really in Asia. So, right here we can say that the argument is valid, because they have so many 8,000 peaks in Asia, we can conclude that argument valid. But is the argument sound? That's what you need to verify. The premises are true, okay? Premises are true. Both premises are true. So 8,000 meter peaks are in Asia. Denali is not in Asia, so we can conclude that premises are true. Okay? And that means the argument is it sounds or not sounds? Yeah. So if the premises are true, then the argument is sound. Okay? Do not hesitate to read in your books and also complete any assignments related to these sections. And if you have any questions, you can reach out, and I'll be happy to provide further information on this one. So reach out anytime, and I'll do my best to get back to you. Take care.